So here we are on 14.1 day 2. It's basically more advanced graphing of sine and cosine, but of course we need to start with plain old-fashioned sine and cosine. If you ever get stuck on which one sine and cosine is, if you can remember that the unit circle would have a spot right there at 1, 0, and then you'd have to remember which one's y. Obviously the 0 is y, but the question is, which function is y like? Come on. Nobody knows whether sine or cosine is like y. Come on, this is honors pre-calc class. Which one is like y? Sine is like y. So sine starts at 0, and cosine is the other one. Duh. It starts at 1. All right, so sine starts at 0, so you should have started right there. And cosine starts at 1. I personally am going to make that the 1 spot. But you could have made it at the top. It would have been fine. But I'm labeling this as my 1 and my -1 here. And I'm going to go to eventually get to 1 and -1 here. And I would do it by dots. I would put a dot here, and a dot here, and a dot here, and a dot there. And then I would connect the dots. That's how I'd do it. Okay, cool. Cosine, similar. I'm going to do it by dots again, so I'm going to make my dots there, and then it goes all the way down to here, and then it goes up to here, and then it goes back up to 1. So I like to think of this as kind of a valley. Go back in and put my dots in. Okay, now I hope that was easy, but now we're going to step it up a notch. The numbers in the front are super easy. They just change your y values. You do not have to regraph your picture. You just have to change numbers on the y-axis. So I'm going to put a 4 here, and I'm going to put a 7 there, and it's just easy to change the numbers. But this is a lot harder when I make the sine here have a 3 right there, and this cosine, we're going to have a 5 right there. Would you please adjust the numbering on the labeling on your graphs to make that work? I'll pause for a minute. And if you have forgotten, it seems like you should make it 3 times all the x numbers, so you don't multiply all your x numbers by 3. Your pi over 2 here, it doesn't get multiplied by 3. All right, it multiplies by something related to 3. I'm going to pause while you try to finish these 2. So today was a really easy day. We had a chance to talk about some interesting visions into the future. And now we're back to, if I put a 4 here, that represents that 4, and I put a -4 here, that's that 4. This one's going to be 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. But this 3 changes all of it. I multiply everything by 1/3, so that becomes 1 pi over 6, and I'm smart enough to count. 1 pi over 6 turns into 2 pi over 6, 3 pi over 6, 4 pi over 6. That is the easy way to do this. All right, on to this one. You should have put a 7 here and a 7 there, and then this 5 here makes this, instead of pi over 2, it makes it, we times it by 1/5, pi over 10, 2 pi over 10, 3 pi over 10, and 4 pi over 10. And let's move on to the next slide. Everybody look at this and make sure you understand all of those things about cosine and sine. I'll pause while you just read those over for a minute. You got to understand amplitude, baseline, the period, the range. All right, so when it says the range is -1 to 1, do you get that just means, you know, it goes between -1 and 1? And domain just means it keeps going in both directions. The domain of this is all reals. It just keeps going. Amplitude is like if you were to make this the ocean, and this is a wave that is on the ocean. I'll use blue for that. Then if the ocean all of a sudden decided to go flat, it would go back to the baseline. And so we really only measure our waves by the amplitude, which is from there up. And it's always positive. So if I have a negative number in front like this, y equals negative 2 sine theta, my amplitude is 2. Even though it says negative 2, my amplitude is the absolute value of that. So the amplitude would equal 2. Will we test you on that? Of course. This is honors pre-calc. We're not just going to give you an easy one. All right. Any questions about domain, range? Do you know what continuous means? Do you understand that they're all smooth, meaning there aren't any little like super sharp points? Okay. All right, moving on. This is the one equation I said was important. The period is 2 pi over b. That is an equation. I'm going to put PER for period. Period is 2 pi over b. So if I tell you b, it's really easy. If I tell you that b is like 7, then you'd put a 7 here, and the period is 2 pi over 7. You know why? Because when it got to 2 pi right here, this is where 2 pi would normally be. If I have a 7 here, the b was 7, that means I divided everything by 7. So now my period is 2 pi over 7. Okay? But this is an important formula because I might tell you the period, and I might say the period is 3 pi. Well, and this wasn't a 7. If I said the period was 3 pi, you could solve for b. Would everybody please write this? 3 pi equals 2 pi over b and solve. I'll wait. Pausing. Oh, by now you have solved this thing for b by multiplying both sides by b and then dividing both sides by 3 pi. And I hope that's what you did anyways. And you'd have 2 pi over 3 pi, and then the pi's cancel, so b must have been 2/3. So right here, this b would be 2/3. If I tell you the period, you can figure out the b. Okay, move on. This one is really critical because of something. Is it because there's a negative in front? No, that's easy. You just flip the graph over. See, your cosine graph looks like this. I'm going to make it with some dots. You don't have to copy this right now. You can just listen for a second. So that's cosine. And if I put a 1/2 in front, yawn, I just put a half here and a half here. No big deal. How about that negative? Do you guys get how to flip something? It means you go like that. That's pretty easy. How about moving everything up 1? That's pretty easy too. You just take all the dots, which are here and here and here and here and here, and move them all up 1. Well, how far is 1? 2/2 would be 1. It's hard to tell what 1 is unless you look at your own labels. And 2. And then this goes up 2 marks. There we go. And now all of a sudden my graph has been there. That green one just moved up 2. That's all the easy part. You know what the hard part is? The inside, of course. So who knows what we should do to handle that inside? Factor it. Thank heavens. Last hour we sat here for about 5 minutes before anybody realized it was factoring. I'm factoring out the 2. Because if you can factor it, you should. So once again, it comes up. That's why I tell you that knowing the basics like factoring is the number one thing for this class. Because if you can't factor now, you'd be stuck. And I think a lot of you can't factor this. And I don't blame you because you really probably have forgotten what factoring really means. Factoring, when you're taking out a 2, you're dividing everything by 2 so you can multiply it by 2 in the front. So you're really dividing this by 2. And so that's what you have left, 3 pi over 2. Process that for a second. So this 2 times x makes 2x. This 2 times 3 pi over 2 would give you the 3 pi that we had. Is it 12 pi over 2? No, wait, 6 pi over 2, which would be 3 pi. Get how that factored? Yes?
Would the 2 now become a b?
Yes, the 2, but if you really look back at it, the 2 was the b either way. You know, like if you could just grab this front number and it is the b. But we really want it to factor out and be right there. And now that's the b. And then that's called the something something. 2 words starts with a p. Anybody know it? Phase shift. That is called the phase shift. Do you get a lot of kids are going to say the phase shift is 3 pi? Because they're going to be like, that's the phase shift. As you said it was the phase shift. Ah, but you got to factor out the 2 first. And then that's the phase shift. Another subset of kids are going to get it wrong because they're going to say the phase shift is just 3 pi over 2. And it's actually directional. So, left or right? Positive and negative is the key, of course, but is it left pi over 2 or is it right pi over 2? Left. Left. All right. Now, this is an important last little piece. This 2 here means I'm going to go through and relabel all my x values. But then I have to shift it this, not this. You would have thought it was going to shift 3 pi. It doesn't. The phase shift is 3 pi over 2. So how far should I shift it? 3 pi over 2. So how far is that? Well, you have to relabel to be able to have a chance to figure that out. Now, that is such a beast that I'm not even going to finish this one because I feel like it's too hard. We wouldn't give you one that's that difficult. Okay. So, let's do one that we would give you. Everybody write this down. Y equals 4 sine of 2 pi minus sorry, I'm wrong. 2x. Sorry, 2x minus pi. And that is in parentheses like this. Okay, so the easy part is graphing the sign and making the numbers on the y-axis be 4s. That's easy. And then labeling these 4 spots. The original numbers are easy. You're supposed to know it ends at 2 pi, so this is pi, so this is pi over 2, and you can count it up. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, and I do recommend that. That's your classic sign. But then you got to get this thing factored right and move it the right distance, and you can tell how far that is after you have factored out your 2 and factored in that you need to multiply all of these by 1/2. All right, finish this off. Sine. Oops. Oops. I should have made my dots. There. There's my sine graph. This is 4. This is -4. Can you do this shift? Pausing for a second. This is the big kahuna for today. If you can do this, then we'll start the worksheet. Okay, so you should have factored out the 2, and then you had x minus pi over 2. How many of you knew that it was pi over 2 right there? Okay, good. Then that tells me I got to move it right pi over 2. How far is pi over 2? Well, this is no longer pi over 2. It's pi over 4. And this is 2 pi over 4. And what do you think 2 pi over 4 actually reduces to? Pi over 2. So that is how far you should move it. That far. Because that is pi over 4. That's how far you move it. I know pi over 2 used to be a different place. 2 pi over 4, which then changes to pi over 2. That's why we move it that far. So, I'd like you to just finish, if you haven't already, move every dot. These are the key dots. Move them all over 2 marks. If you have never done one for real, how can you test on it? And the test is not this Thursday. We could have, We're going to do a quiz on Thursday, but yeah, you know that the end of the week for us is Thursday. I mean, I have a work day on Friday, but you guys will not be testing there. When you come back from break, we'll obviously review, and then we'll even do a little bit more stuff. And then you'll test by like maybe Wednesday or Thursday after you've come back from break. All right. Did you move everything over 2 spots? In my opinion, the smart way to do that is to move this one over first. I know that's weird. But this other one's kind of weirder because you move it over. I'm going to use green here. You move it over 2 marks and it's right on top of where it used to be. So I'm going to use a new color here. This goes over 2 marks and it'd be about there. This goes over 2 marks and it'd be about there. And if you just look at the green marks, you might be able to follow this. Now it's the green one, and it's moved over 2 marks. And why would Mr. Server cry a little bit and then mark it wrong?
Because you forgot to mark the 2 inches.
I didn't label this spot or that spot. Remember me saying that was one of the biggest reasons that we should call this 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, because then I can say it's 5 pi over 4 and 6 pi over 4. And I even said as an extra bonus for doing it this way that if you don't reduce this, I'll be okay. But I will say that if you're trying to be the ultimate pre-calc student, you should reduce whenever you can. So yeah, at the end, after I'd counted 1, 2, 3, 4, 5, 6 pi over 4, I would go back and reduce the ones I can reduce. No, I won't mark it wrong, but it's the way it should be. So that's technically 3 pi over 2 at the end. But I won't mark that wrong if you don't. Okay, cool. So if you understood that, that was the hardest thing, that learning how to do a phase shift and factoring out something like that, like this. That was the biggest thing for today. So now, here comes your worksheet. I would like you to clear off your desk and set something to write with. Totally okay with you working with the kid next to you. This is not a test. Take one, pass back. Take one, pass it back.